Okay, so welcome to the Unit 5 Day 1 video. Our new unit is going to be on radical expressions. So today we're going to be focusing on simplifying radical expressions, including multiplying and dividing those expressions and then simplifying. So today's objectives that we're going to be working on are simplifying radical expressions with indexes of 2, 3, or 4, multiplying and simplifying radical expressions with the same index, and dividing and simplifying radical expressions with the same index. All right. So first, a little bit of notation here is when you see this little symbol here, understand that this n stands for the index. That is the index of this radical expression. This is the radical sign. And B here is called the radicand. Alright, so the index is the number outside the radical sign, but it's not a coefficient, right? It's kind of raised, kind of like an exponent, but not. It's the index. Alright, so let's see what it looks like here in our problem. So a couple properties, and you can read this on your own. I think reading it's a little bit confusing, so it's probably just easier to show you what it means. So if I'm looking at negative 4 to the third power, I'm going to get negative 64. Right? So that means the third root of negative 64, right, would be negative 4. Because you could rewrite that as the third root of negative 4 to the third power. Right? So really understanding that radicands with higher indexes just undo larger exponents. So the third root undoes the third power, or a cube root undoes a cube. Alright? So same thing if we're working over here with even numbers, 3 to the fourth power. Now you're going to, anything to the fourth power is really a square times a square. So 3 squared times 3 squared is 3 to the fourth, or 9 times 9 is 81. So that might help you when you're trying to find the fourth power. Just square the number and then multiply it by itself. So that means the fourth root of 81 is really the fourth root of 3 to the fourth power. So I get 3. All right. Now, notice I didn't say plus or minus 3 because I didn't take the fourth root of a variable, right? It's not an equation. I'm not trying to solve for a variable. So there's a difference between a principal root, right, which we'll talk about. So anytime n is even, if the radicand is positive, so that 81 was positive, there are still two roots, right? Two real roots, right? Probably just write that in there. Two real roots. Okay? But really all we're going to care about is the positive. So the positive root is the principal root. Meaning that's the one we care about, right? We're only going to take the positive root. So if I have the fourth root of negative 2 raised to the fourth power, I get 2. If I have the fourth root of positive 2 to the fourth power, I get 2. Right? Negative 2 to the fourth gives you 16, right? This is the fourth root of 16, which is 2. 2 to the fourth also gives you 16. But again, when we're simplifying radicals, we're always just taking the principal root. And again, the principal root is the positive root. That's the only one we're concerned about, except when you're solving an equation. So try to keep those two situations separately, and we've talked about this before. Now, what if the radicand is negative? If the radicand is negative, then there are 0 real roots, right? Doesn't matter what index it is. You cannot take an even index of a negative number. So the fourth root of -16 has no real solutions, right? So there's a lot that we just kind of showed in these very similar problems here. So make sure you kind of discern that and ask us questions if that doesn't quite make sense. Now, over here when we're talking about the nth root, when the index is odd, it's a little easier to remember because there's only one root, only one real root. So, if I take the third root of 8, it's always 2. Whereas if I take the third root of -8, I get -2. Right? There's only one. There's never a plus minus with an odd index. Right? If the index is odd, it's always the same sign, right? So if I had the third root of 3 to the third power, it would be 3. If I had the third root of -3 to the third power, it would be -3, right? The odd roots always keep the sign. The even roots, you'll always give me positive numbers, okay? So hopefully this is a good introduction to radicals with higher indexes. We'll do a little bit of practice here. So again, you're trying to break this down. Previously we only had numbers that were perfect cubes or perfect fourth power numbers. -54, if I break that down, that's 27 times 2. Since it's negative, I'll keep the negative with the cube. 27 gives me -3 to the third power times 2. So again, we can apply that here. You get -3. The 2 isn't able to get out because it doesn't have a third root. Make sure that you keep that index in the same position. The index needs to be with each of these. Don't drop it. All right? So try to give these next couple problems a try, and then we'll come back with the answers. Pause the video. Okay, so here are the answers that you should have for the first 3 practice problems. Take a look through there. Notice the similarity between number 2 and number 3 in terms of taking the odd root of -3 to the third power and the even root of -3 to the fourth power. See how that affects the differences. All right, so let's see what this looks like now when we're talking about radical expressions with variables. You're basically doing the same thing. You're just going to have more things to work with. So 32, and another little side note here is that if you're not good with these properties of exponents, there is a supplemental video that you can watch that goes over the properties of exponents. That should be posted very soon, and that might be good to watch if you have any trouble with exponent properties. All right, so 32, that is going to be 2 to the 5th power, x to the 4th, and y to the 7th. So if I write it like that, now I can start to use those exponent properties and know that 2 to the 5th is 2 to the 3rd times 2 squared. Y to the 4th is y to the, let's look at x to the 4th. So that's x to the 3rd times x. Y to the 7th is y to the 6th times y. Now, the sixth is really y squared raised to the third power, right? And all of that's under the third root. So why did I do it that way? Because this 2 to the third reduces to 2, x to the third, I can just kind of cross those out as I use them. X to the third will reduce to x, y squared to the third reduces to y squared. And that leaves me with 2 squared, which is 4, x, y. Okay, again, breaking it down into the kind of its prime factorization is kind of what you're doing here. Breaking it down into numbers that I can take the third root of. Right, so go ahead and pause the video and try number 4. We'll come back and I'll show you the answer to number 4, and then we'll pause it again and try number 5. So pause it and try number 4. Okay, so here's the answer to number 4. And let's kind of just talk a little bit about it. You got to recognize 64 is 2 to the 6th power. And that's just going to come through repetition. But if you can prime factor it, the 32 times 2, that breaks down into 16 times 2. 16 is 8 times 2. So if you know this is 2 cubed, there's 3 here, you have another 3 there, so that's 2 to the 6th, right? 2 to the 6th, which I have. And then I broke down these values into numbers that can easily divide by 4. So out of 6, I can divide it 4 and 2. 9 gives me an 8, which will divide by 4, right? So x squared to the 4th. And the 14, I broke it up into 12 and 2, because 12 divides by 4 to give me 3, right? So that explains why I have the x squared here and the x and the y to the third on the outside. So this is probably the trickiest part about reducing these radicals. But the more you do it, the better it should get. Just try to practice and ask questions if you're confused. The feedback that we give you will help you get better. All right, so just keep trying. Note this one is a 5th root, so let's see how this looks. Pause the video and try this next problem. Okay, so here is our answer to number 5, 2x y squared to the 5th root of 2x to the 4th y to the 4th. So notice it's kind of the same breakdown. It's still 2 to the 6th. Because my index is 5, I'm looking for factors of 5. So 2 to the 5th, x to the 5th, y to the 10th, because 10 divides by 5. So that kind of adjusts how I break down that x to the 9 in problem 4, and how I broke down x to the 9th in problem 5. It all depends on what the index tells you. Break it down in a way that's helpful for you. All right? So let's go on to the next problem. Multiplying radical expressions with the same index. So this is pretty straightforward. It kind of follows the property of multiplication of exponents. As long as they have the same indexes, they're both n. So then I keep the nth index, and it's a times b. So what would that look like? Let's say I had the cube root of 3 multiplied by the cube root of 18. Well, that gives me the cube root of 54, which is just 3 to the 3rd power times 2. So the 3rd root of 3 to the 2nd power, which gives me 3 3rd root of 2. Right? So we don't always necessarily need to multiply the numbers together. Sometimes it might be easier, if this is what I'm looking for is 3 to the 3rd power, realize that's 3 to the 1st, and this is 9 times 2, which is 3 squared times 2. So 3 times 3 squared gives me 3 to the 3rd, and then the 2 is left under. So a couple different ways to kind of look at this. It all depends on which way makes sense. If you can multiply it to get 54, then do that. But sometimes it's easier to break down smaller numbers and just add the exponents. Again, that's going to be a personal choice for you. So the first example here is the fourth root of 3 times the third root of 2. You can't simplify that. Can't use this property. So we'll show you how to do this problem later on in the unit. Right now, if they don't have the same index, you have to ignore it. You can't use this property when the indexes are different. So let's look at our next example. So we get the third root of negative 16. Well, I know that 4 is 2 squared, right? So really I'm looking at the third root of 2 squared times 2 squared, which is, well, actually we have negative 2. Right? So this is negative 2 to the 4th power. Right? Negative 2 to the 4th power. So I can take that out and get, breaks down into negative 8 times 2, or negative 2 to the 3rd times 2, which gives me negative 2 third root of 2. And then we'll try this next one again. We get the third root of negative 8, x to the 9th, y to the 3rd. So that gives me negative 2, x to the 3rd, y. Alright, pause the video, practice these next couple problems. Okay, so here are the answers to 6, 7, and 8. If you didn't get these answers, then make sure you ask us in class when we start going over these again. Alright, let's move on to the last property here, combining radical expressions. So again, this follows the same type of thing with the multiplication. If you're dividing two radicands, all you have to do is make one problem with the same index, and it's a divided by b. So what does that look like? Let's look at an example here. And we have the third root over the third root, so it just becomes the third root of negative 64 x to the 5th divided by 4 x to the 4th. 64 divided by 4, negative 16 x. So the third root of that gives me negative 8 times 2 x. Third root of negative 8 is negative 2, and I'm left with the third root of 2x. Alright, you should be getting somewhat used to this, so go ahead and try 9 and 10, and I'll come back with the answers in just a moment. So pause the video. Okay, here are the two solutions for 9 and 10 to the number 9 and 10, and go ahead and take a look at those. If those are not the solutions you arrived at, go ahead and see if you can work your way backwards and see why these are the solutions. If not, come and talk to us. We'd be happy to work it out with you and show you the answer. So that's the end of our video for day 1, and we will see you next time you're in class.